Alright, so in the last video, I thoroughly talked about the RNN architecture and its different components of RNN and how it also suffers from vanishing gradient problem when working with a long-term dependency, right? So in this video, I wanted to take you through like how to do a code implementation using Pytorch RNN and how we can implement a Pytorch RNN module for doing a time series forecasting, right? So the code which I will use, I just wanted to give the credit to this blog post from Jason Brownlee, which is nothing which is coming from Machine Learning Mastery blog, and there we have this data set which is nothing but air pollution forecasting. And in that data set, like, we have these are the features which are present, and we are trying to predict this PM 2.5 uh, concentration, which is an indication of the level of population at each hour. And this is the data is recorded at a 5-year interval at the US Embassy in Beijing, China, right? So this is the data set which we will use, and so based on this the different types of features, we will try to predict what would be the pollution at the next hour, right? So with this, let's get started. Let's move to our code now. So at first, like, we are doing certain imports which are like very basics. Then we are kind of pointing out the file where this data set is present. So again, this data set is coming from Jason Brownlee's GitHub repository, and I am just reading that, and we are getting this data set. So this is how the data set looks like at this point. Now we will do some data pre-processing. So it has been seen that the PM 2.5 is not present for the first 24 hours in this data set. So we need to drop those 24 records from the data set. Also, we can see like we have this year, month, and day, which are like three different columns, right? So you can see like this month, day, and hour, along with the year. These are like four data points which are there, that we will concatenate and create a single column. And you can also see like PM 2.5 is null at least for first 24 records. So we will kind of drop those records, and our target variable is this PM 2.5, right? So this is our target variable, and our the features are all this. And using all these features, we will try to predict what would be the population at the next hour, right? So let's move on. So the data preprocessing, what I was mentioning, I'm just parsing the date time column and creating a single column out of it, and we are making that date time column as index of the data frame, right? So once we have that data, we are just doing some manipulation, that we are giving proper column names for the data frame, and we are also renaming the index to date column. Okay, and also we are kind of ignoring the first 24 rows where we have PM 2.5 equals to 0. Now just checking the shape and also the tail of the data set, and we have data starting from 2010 to 2014 with 8 columns, right? And also we have a column which is WLD direction. So that is kind of a categorical column where we have values like SC, CV, LW, and E, right? So we will do a level encoding on top of that data, and we will convert that data to like numerical representation from categorical representation, right? So once we have done that, we will also normalize our data set, because we have seen in the previous videos I talked about like how normalizing the data kind of uh, like stabilizes the learning process in neural network, right? So with that, we will kind of normalize our features, and after that we will do certain data preparation steps for this time series, right? So if I just do a visualization of how we will try to like model our data, or how we will prepare our data. So we have our PM 2.5, right? So just take the pen. So this is our PM 2.5 at T timestamp, right? and we have the weather conditions. So all those weather condition would be a shifted value. So like t while as well, so that is for like one of the feature, like that is for feature 1. Then we have feature 2 where we also have t while as well. Then feature 3 for t while as well. So all these features will be present, which will have the values of t while as well for different time periods, and we will have the PM 2.5 at the current timestamp, right? So looking at the past hour data, we will try to predict what will be the current hours PM 2.5, right? So I hope you got an understanding of how we will prepare the data. So our all the features values will be shifted by one place, and that would be previous hours value, and our PM 2.5 will be the current hours value. So looking at the past 1 hour weather condition, we will try to predict what will be the PM 2.5 at the current hour or the next hour, right? Okay. So with that, so this is like we have used the pandas shift function to create this lag of features. So just I have taken a dummy data. I'll try to explain what this shift minus 2 and shift 2 will do. So you can see this is our data, original data, and this will what will happen if you do a shift minus 2, right? So all the values will be shifted. So the third row will become the first row here, and similarly the fourth row will become the second, and the fifth row will become the third row, and this two will not have any data because we do not have the data to shift all these two rows, right? So similarly we will have for the shift plus 2 we will have this type of data, right? So the first two will be done, and all the previous rows will be shifted by two places, right? So this is the basic concept of how you can use the pandas dot shift method to create the lag features, and we kind of use that in this series to supervised function. Actually, this the credit goes to this again machine learning mastery.com blog series or the blog post. So we are kind of creating the lags. So we so here you can see like n in is nothing but the number of lag observation at input x, right? So these are working with the features, and it will create lag features on the input data, and n out is nothing but the number of observation at output y, right? And we are also taking the data as input, and it is kind of returning a data frame which will kind of be a supervised, so it will convert the time series data to supervised, and it will return the data frame out of this function, right? So if you see, if I pass my scale data inside this function series to supervised, so we will get back our data in this way. So you'll see like this is our target variable, which is a current timestamp, the PM 2.5 value, and all the features are have a shifted value, right? So this is like feature 7 value of t minus 1, this is feature 6 t minus 1. So all these values are a shifted or a lagged value of the features. So for this particular row we have all the 8 features, the corresponding 8 features, and based on that we will try to predict what will be the next hours PM 2.5 level, right, or the pollution level. So we don't need the values which are like variable 2 to variable t. So these are like shifted values of the target variable. So we will not lead this. So we will kind of drop these values, right? So here we will kind of drop those columns, and we will create a new data frame where we have the shifted values of the features and also the current timestamps vr1t, right? So this is my target variable. So these are my target variable, and all these are till this point these are like features which are shifted by 1, right? Lag value of 1. So I hope you now got an understanding like how we converted the time series data to a supervised problem, and based on the feature values which are like past 1 hour data. So using the model will look into the past 1 hour data, and it will try to predict what would be the current hours PM 2.5 pollution level, right? Okay. Now what we will do is we will use the first 4 years data as trailing data set, and 1 year data as a test data set. So these are like very basic steps where we are converting the data to the required format which we need for RNN. So in case of RNN, if you remember, we need the data in the L cross T cross D, right? So L is nothing but number of features. Sorry, this is the D is actually the number of features. So L is your the number of rows, right? Apologies for that. And T is the sequence length, right? How many timestamps data we are looking to make any prediction, right? So here we can see like these are the number of rows. So we are only looking at the past 1 hour data, so that's why this T is equals to 1, and D is the number of features. So we have 8 features in our data set, so this value is 8, right? So this is our X trail, right? So this is X trail, this is Y trail, Y trail, and similarly we have the test data set also, right? So I hope you got an understanding what the manipulations we are doing at the data level, to so that the uh, data is at the shape of like L cross T cross D, right? So once we have that, we kind of create the tensor data set and the data loader of Pytorch, and we are checking the shape of one of the batches. So we are creating a batches of a size 256. So our shape of the data set is like for a particular batch is 256 cross 1 cross 8. Now what we will do is we will create the class of RNN, right? So in RNN, what we will do is we will use this concept of we use this module from PyTorch nn.rnn, and here we will kind of give the inputs which are like input size, hidden dim, number of layers, and also we will mention that batch first equals to true because the first dimension is the batch size, right? So if you just take a close look here, the shape of or the function nn.rnn takes the input size as the first parameter, then the hidden dimensions, right? And if we stacking multiple layers in the RNN or not, so that will be like n layers, and then batch first equals to true or false, right? So that we are kind of using here. So once we kind of do that, then we will add a fully connected layer or a linear layer on top of the RNN layer, right? And there we will kind of squeeze the values. Okay, so here you can see we are getting the output, and there here we are kind of squeezing my sequence length and hidden dimensions before passing it to the fully collected layer, right? So after that, the forward function is there. Here at first we are passing our data through the RNN, then we are kind of converting our data to this shape which is like batch size comma sequence length multiplied by hidden dim, because previously we have the output of RNN is three-dimensional data, but if you want to feed it to a fully connected layer, we need to convert it to a two-dimensional data, right? So we are kind of squeezing this sequence length and hidden dim, and we are converting to a two-dimensional data, right? Then we are passing it through the fully corrected layer, and we are getting the output, right? So I hope you got an understanding what are the manipulations or the changing of shape which we are doing in this class, and that is very crucial if you want to understand the RNN. Then few of the parameters like input size equals to 8, output size equals to 1, hidden dim equals to 512. So we are not stacking RNN, so that's why the n layers equals to 1, and the sequence length is equals to 1 also. So we are just looking at the past 1 hour data, and we are making predictions on top of that data. Okay, then we are instantiating the RNN class. So after the instantiation is done, we are creating our loss function, which is nothing but mean squared error, because this problem is nothing but we are trying to measure the predicted PM2.5 concentration with the actual PM2.5 concentration, right? So we are kind of doing a regression problem, so we can use the mean squared error, and we are using Adam optimizer. Then the training loop. So this training loop is what we have talked about so many times, so I will not go through it. Just one of the thing which I wanted to check here is, so in some of the cases, actually in the last iteration, your batch size may not be of the same shape of 256, right? So that we will check, and we will kind of ignore that batch. So if you just look closely, I am checking if the uh, for the particular batch is the shape is equals to batch size or not. If it is not equals to, I will just skip that batch and I will continue for the rest of the batches, right? So that is the only one thing that changes here. Rest of the thing is as it is. So you can see like loss is going down here, and after that we can check the model performance on the test data set. So we are just making prediction, then we are converting it to numpy array so that we can do like we can convert it and scale the data and scale it back to the original scale, right? So after that we can see our uh, test RMSE is 41.283, right? So this is what the mean squared error or the root mean squared error we are getting on the test set using a sequence length of wall, right? So next we can increase the uh, t value, right? So if you remember, our data is L cross T cross D. So at first we tried with t equals to 1, like looking at the past 1 hour data. So looking at only t minus 1, we were trying to predict what would be the current PM 2.5 air pollution, right? Now what we will do is we will also we will increase the sequence length from t minus 1 to t minus 2 and t minus 3. So here your t will be 3 here, right? So looking at the past 3 hours data, we will try to predict what would be the uh, current hours PM 2.5 level, right? So here the sequence length will be equals to 3, right? So with that we are also again doing the same steps. We are reading the data, then we are scaling the data, and after that if you see here, the number of hours I have mentioned equals to 3. So that is the only change which I have done here, because we will look into the past 3 hours data, and based on that we will try to predict what would be the current hours, uh, looking at the past 3 hours data, what would be the current hours PM 2.5 value, right? So you can see like we have okay, so we can see like here, looking at the like t minus 1 to t minus 3. So this is our target variable, which is uh, where wall equals to t. So this is our target, and now we will create 3 lags for each of the features, right? So if I just scroll here, so you will see for each of the variables we will create t minus 1, t minus 2 and t minus 3, right? So with that we will put more hours data into the model. The sequence length equals to will be equals to 3, and based on that we will try to predict what would be the current time times PM 2.5 pollution level, right? So after that, like the same things, like we are using 4 years data in the trailing data, and we will make prediction on the 1 year data, right? Then we are also here you can see I'm mentioning the sequence length equals to 3. So if you look in the previous section, there I mentioned sequence length equals to 1. So that is the only change which is happening here. Rest of the things are pretty much similar. I am running the trail loop. So here after trail loop, we are also making the prediction at the test data set. Then we are like bringing the test data set into the normal scale, and then we will check the root mean squared error. So here we can see the root mean squared error is much more smaller, right? So here it is 25.573. Previously it was around 47 or so, higher than this value, right? So we have seen that if we increase the sequence length from 1 to 3, where we are putting more signals into the model, like we are asking model to look at the past 3 hours data to predict what would be the current hours pollution level, right? So yeah, that's all I wanted to discuss in this video. So I hope you got an understanding of this, how we can use the RNN, and we can implement RLL for a time series prediction, right? So you can play around with different learning rate. Then also you can stack multiple RNN layers. Also you can try increasing the sequence length from 3 hours to a 5 hours window, and see if the model output is giving you more accurate results or not. So those kind of experimentation you can try it out, and also you can let me know in the comment if you are getting a better results using a different configuration of the model parameters, right? So I hope you like this one. So this is a very interesting real world problem which I talked about in this video. So yeah, that's all I have for this video. I hope you like this one, and if you haven't subscribed this channel, please subscribe and share this content with your friends. Thank you. See you in the next video.